Hello, and welcome to Target 6A, where we're going to remind ourselves how to graph inequalities in two variables. Ultimately, the goal of this unit is to graph systems of linear inequalities, but first we need to talk about how we're going to graph a linear inequality when it has more than one variable. In previous units, we have gone over graphing inequalities on a number line, but that's when we just had one variable to deal with. Now we're going to have x's and y's, so the way we're going to solve them is by graphing them on a Cartesian plane. Now let's talk about the steps we're going to take to graph. We're going to start by graphing the line, or the first step to graphing an inequality is the same as graphing a regular line. We start by, by graphing the y-intercept, then a second point using the slope. Alright, so the laws of geometry state that in order to have a line, we need 2 points. So there we have it. We have the y-intercept, then we follow the slope up and to the right or down and to the right for a second point. The next step is to decide what type of line is going to connect those 2 points. When we graph inequalities, we have two possibilities. First, we have a symbol like greater than or equal to or less than or equal to. These are going to be solid lines. They're gonna, oh no, let's not make it straight, let's do a diagonal. They're gonna look like this or like this. Now, if we have just a greater than or just a less than, these are going to be dashed lines. They're going to look like this or like that. Then we need to decide on where we shade. If we have y is greater than or equal to, or y is greater than, we shade above the y-intercept. And if we have y is less than or equal to, or y is less than, we shade below the y-intercept, the y-intercept. Okay, let's do all of that, because that's just a bunch of things to write down to guide us, but let's check it out. In number 1, I'd like to graph the inequality y is greater than or equal to 2x plus 5. First, let's identify the slope in the y-intercept. This is my slope. It's 2, so really it's 2 over 1. And then here's our y-intercept, so our y-intercept is 0, 5. Before we graph those 2 points, from step 1, let's decide, actually no, let's graph the 2 points, JK. Alright, let's start with the y-intercept. There it is. And then, oh, whoops, well, I messed up on my graph, but that's okay. Next, we're going to follow the slope by going up 2, to the right 1, my bad. Those are 2 points. Let's move on to step 2. Step 2 is deciding whether or not we have solid or dashed lines. We have a symbol that looks like this. I'm just rewriting it so we can see it better. It has a line underneath the symbol, so that tells me that the line is solid. The shading. Y is less than or equal to, so we're going to be shading below the y-intercept. Let's do it. We're going to have a solid line connecting. and we're going to shade below. Now I'm going to shade using a highlighter, but this is how I used to shade back, when I was just using a pencil, like this. This is good enough for shading, but I have beautiful technology, so I am going to shade like this. Wow, how pretty. Everything in this shaded area is a solution to my inequality. And anything on the line is a solution because it's or equal to. Well, let's check it out. Is 4 comma 0 a solution? Well, 4 comma 0 is right there. It's inside the shaded area. It's a solution. Here is another solution to the inequality. How about, I don't know, 0, 0? You could have chosen any point you like. I think it's going to be different every class I do. But I just chose 0, 0 here. One other thing that is a solution is the y-intercept. We could have also said 0, 5. That's for sure a solution because it's on the solid line. On solid line in shaded. That one is also in the shaded area. Let's do another. All right, let's identify the slope and the y-intercept first. The slope is 1/3. The y-intercept is 0, -4. Let's graph those 2 points. 0, -4. Our slope is up 1 to the right 3. We have y is greater than. Greater than. That is going to be a dashed line. If you're not sure, you can always look here. Now, the way I remember which one's dashed and which one's solid lines have the symbols that produce solid lines have solid lines underneath the symbols. This symbol does not have a solid line, so it's going to be dashed. Dash, 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 dash. Shading, above or below. Y is greater than. Greater than means we're going to be shading above. This is the y-intercept. We're going to shade above it. Beautiful. Okay. Is -3 and -3 a solution? Well, let's see. -3 is right here. Yes, it's in the shaded. What else is a solution? Here. 3, -1. Anything in the shaded area would be a solution. 0, -4 is not a solution because it is on dashed. Let's try number 3. First, let's identify the slope, -3/5, and the y-intercept. Now, there's nothing being added. What's nothing? It's 0. So our y-intercept is 0, 0. Let's graph those 2 points. There's our y-intercept, and then we're going to go down 3 to the right 5. How are we going to connect it? Well, this is a y is greater than. Greater than is going to give us a dashed line. Dash, 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 dash. And the other way too. Y is greater than, so we're going to be shading above the y-intercept, above it, that away. Perfect. Is -2, 4 a solution? -2. Yes, it's a solution. Another solution would be, I don't know, 4, 2. Is 0, 0 the y-intercept a solution? No, it's not a solution. It's on the dashed. Fantastic. Do we got one more to practice on? No, we're going to go the opposite direction in the next part. I think I'm just going to keep it as one video. Why not? I'm on a roll. The next thing we're going to do is just go the opposite direction with number 1 and for A and B. Instead of instead of graphing the inequality, let's write the inequality that represents the graphs. I think that's what I wanted to do with this whole part. Yeah, fantastic. Okay, so what we needed to do in order to graph inequalities is first we identify the y-intercept, we identify the slope, and we graph them. So let's identify the y-intercept of the slope. All right. Well, I have the y-intercept. It's 0, -6. Now, I can't keep going down into the right, but I still do have a point right here and right here that I can use to find the slope. I do see that it's going down. It looks like it's going down 1, 2, 3, 4, and to the right, 2. Okay. So our slope is y. There's going to be, sorry, when I said slope, I really meant our equation, our inequality. Is going to start with a y. There's going to be some symbol here. I'm not sure yet, so I'm going to leave it blank. Our slope is -4/2 x, and our y-intercept is -6. Now, some of you might see how we can already reduce the slope, but let's give it a second. Let's decide on our symbol first, and then we can reduce the slope. All right, our line is solid, which means our symbol will have a solid line underneath it. That's the next step we took, is we decided whether it's solid or dashed. After that, we decided where we would shade. If we had a greater than symbol, when we were graphing inequalities, we would shade above the y-intercept. If we had less than symbols, we would shade below the y-intercept. This is our y-intercept. It's 0, -6. I'm going to re-highlight it. Is the shaded area above or below it? Well, if I draw an arrow going up for above, it goes into the white space. If I draw an arrow going down for below, it goes into the shaded area, which means I have less than. Y is less than or equal to, let's reduce our slope to -2. X, and then -6. Let's try it again. So step 1 is the y-intercept and the slope. Let's identify. Here's our Here's our y-intercept, which is 4. And then, oh yeah, I had my y-intercept in green. Let's do it that way. And now let's count our slope. It looks like I'm going down again. I'm going down 1, 2. Ooh, where should I stop? Oh, there's a nice point right here. So I'm going down 2, to the right 1. So our slope is -2/1. We got y. There's going to be some symbol there. Our slope is -2/1. And then x. Our y-intercept is +4, so I'm going to write +4. Okay. Can we reduce the slope? Kinda. We could just write it as -2. So I'm just going to keep it this way. I don't need to rewrite it as just a whole number. That's fine. Let's decide on our symbol. Our line. Is it dashed or solid? In this case, it's a dashed line, which means our symbol will not have a line underneath it. Well, now we need to decide whether it's greater than or less than. So let's take a look at the y-intercept and see where is the shading in relation to the y-intercept. Is the shading above the y-intercept? Or is it below? Well, when I drew my arrow going up, I ended up in that pink shaded area, so it's above. So y is greater than -2/1x plus 4. Okay, I will rewrite it as a whole number. Okay, there we go. Fantastic. Let's try it for number 2. Now, number 2 has a weird one. This is a line going up and down. It passes through one of the axes. It passes right here. Does it pass through the x-axis or the y-axis? It passes through the x-axis. It never crosses y because it's going up and down. This is an x line. So instead of y is greater than or less than or equal to something, we're going to have x is greater than or less than or whatever to something. Well, we cross at -2. So x is going to be something to -2. Where is the shaded area? Is the shaded area where x is bigger than -2 or where x is smaller than -2? Well, it looks like the shaded area is going to the right. To the right is greater than. Since it's a dashed line, I'm going to keep my symbol the way it is without putting a line underneath it. Take a look at letter B. It's kind of the opposite of letter A. This one is only crossing through the y-axis. So this one still starts with a y, but there's no slope. It never crosses x. Well, it has something to do with that 3 that y is crossing. Let's decide on the shaded area. Is the shaded area above the 3 that y is crossing or below it? It looks like it's above it, so y is greater than, and since it's a dashed line, I'm going to keep my symbol the way it is. Let's try 2 more of these strange ones, and then I have work for you to practice. Letter C. This is another one going up and down. Is it crossing the x or y axes? This one's crossing x. It's crossing x at -1, so x has something to do with -1. Let's decide if it's greater than or less than. Is the shading on this graph where x is getting larger or where x is getting smaller? Well, hopefully you can tell that the shaded area is to the left of this dashed line, which means that's where the numbers are getting smaller. So x is less than -1. Since it's a dashed line, I will not be putting a line underneath my symbol. Letter D. It's another line that's going up and down. Is it crossing the x or y axis? It's crossing the x-axis, so it has something to do with the x. It's crossing the x at 3, so there's some sort of relationship between x and 3. Let's decide where it's shaded. Is the graph shaded to the side where the x's are getting larger or smaller? it looks like it's shaded to the right. And to the right, the numbers are becoming bigger than 3. So x is greater than 3. Since this is a dashed line, I am not going to put a line underneath my symbol. Okay, so that's both directions of graphing linear inequalities in two variables and writing the graphs of, or I guess the inequalities to the graphs of linear inequalities in two variables. If you have any questions, please make sure to ask myself or whoever else is helping you out with this. Otherwise, have a wonderful rest of whatever day it is for you. Bye!